Here we have a problem on derivative. That is given that y equals to ln of x square positive 5x positive 7, find dy over dx using chain rule. So here we have a function that is y equals to natural logarithm of x square positive 5x positive 7. And the question clearly says that we have to find the derivative of this function using chain rule. Okay, so here when I consider the stuff on the right side of the given function, we have a natural logarithm of a quadratic expression. Okay, instead of this expression, what if I have just ln x and I want to find derivative of this one? So already we know the derivative of natural logarithm of x is equal to just 1 over x. So at the place of x over here, we have an expression. That's a trouble we have in the given function to get derivative. If I just have x over here, the derivative of ln x can be as 1 over x. So at the place of x square positive 5x positive 7, I need single variable. That is the argument of this logarithm must be single variable so that I can get derivative of this one easily. Okay, so for that, what I'm going to do is I'm going to assume let t is equal to x square positive 5x positive 7. Okay, so I just assumed a new variable t for this expression. Then the given function will become what? Then y is equal to ln of t. And already we know that t is equal to x square positive 5x positive 7. Okay, according to the question, we have to find dy over dx. Okay, so let me write dy over dx here. So dy over dx. So what is meant by dy over dx? That is, we have to find derivative of y with respect to x. Okay, here, can I find derivative of y with respect to x in this function? No, I cannot, because y is not a function of x. Only if the y is a function of x, we'll be able to find derivative of y with respect to x. But here, y is a function of t. So we can find derivative of y with respect to t. So it can be written as dy over dt. Further, t is a function of x. So we can find derivative of this t with respect to x. So times dt over dx. So this is called chain rule. So our ultimate aim is to find the derivative of y with respect to x. So I start with dy in numerator of the first fraction. I end with dx in the denominator of the second fraction. So this is called chain rule. Okay, now let's write dy over dx equals to d times. So we can plug in ln of t for this y. So d of ln of t over dt times d of, for this t, we can plug in this stuff, that is x square positive 5x positive 7 over dx. Okay, now let's find the derivative. Dy over dx equals to, okay, already we know that the derivative of ln x with respect to x is just 1 over x. Then what is the derivative of ln t with respect to t? So it's very simple, it's just 1 over t. Okay, times, now I have to find the derivative of this expression with respect to x. So what is the derivative of this x square? So we have to use the power law of derivative. What is the power law of derivative? Let's consider x to the nth power, the derivative of x to the nth power, that is x to the nth power prime. So I have to bring this exponent in front of the variable, and I have to subtract 1 from the exponent. So now x square is exactly in the form of x to the nth power. So what I can do is I can bring the 2 in front of x, and I have to subtract 1 from this exponent 2, then it will become 2 times x to the first power. So whenever the exponent is 1, we don't have to mention, simply we can leave it. Okay, here now I have to get the derivative of this 5 times x. So here 5 and x are multiplied. So when I want a derivative of two terms multiplied where one of the terms is constant, I have to keep the constant as it is and find the derivative of the variable alone. So when I find derivative of this x with respect to x, it will just become 1. Okay, so what is the derivative of this 7? So it's a constant. 7 is a constant. The derivative of a constant with respect to any variable will be 0. So the derivative of 7 with respect to x will become 0. Okay, so dy over dx equals to 1 over. Okay, actually t is a variable taken by us. So we should not give our answer in terms of the variable t. So it has to be replaced by the original stuff, that is x square positive 5x positive 7. Now we can plug in this expression for t. So I'm getting 1 over x square positive 5x positive 7. And when I simplify the stuff over here, 2x positive 5 times 1 is just 5. And we can ignore the 0. So dy over dx equals to, when I multiply this 1 and this 2x positive 5, I'm getting 2x positive 5 over x square positive 5x positive 7. Okay, I got the derivative of the given function. So the derivative of the given function equals to 2x positive 5 over x square positive 5x positive 7.